Hello, what's up everybody? For today's video, we're gonna talk about combinational circuit design. So, without further ado, let's just start. In simple terms, a combinational logic circuit is a series of output only depends on input at that time. There is no memory that contains information from previous values. There are three ways to design combinational logic circuit. The first is using primitive gate, second using the bitwise operator, and third using case.
A multiplexer is a device that selects one of several analog or digital input signals and forwards the selected input into a single line or output. A multiplexer is one of combinational circuit. A multiplexer of 2 to the power of n inputs has n select lines, which are used to select which input line to send to the output. The select line is we called by selector. The selector will select what input will be selected through the path according to the select value.
For input multiplexer, we'll choose one of the inputs that will be passed through the path. So, if we have 4 input multiplexer, how much selector that will be we need? So, we can count it to log base 2 of m is equal to n, with m is input line and n is selector. So, we can assume that log base 2 of 4 is equal to n. And then n value is 2, so we need 2 selector.
The 4-input multiplexer can be constructed using 3 MUX with 2 inputs, as we have multiplexer with 2 inputs, so we just need 1 selector each multiplexer. Now, we will discuss about how multiplexer works. As we can see into the diagram, if the value of the first selector is 0, the input will be chosen are x0 and x2. On the other side, if the value of first selector is 1, the input will be chosen are x1 and x3. Now, how about the second selector? You can determine it by yourself, right? Yes, it depends on the first line output that will become input of the multiplexer with selector 1, and it has same pattern.
And now, for the following videos, we're gonna show you how to design a combinational circuit using a Xilinx software. Let's do it. Now, first we're gonna using the primitive gate. Primitive gate are using the schematic input. Gates are already available as a library. Look for the gate in the symbol name filter column. Drag the symbol into the workspace board. Add a wire to the gate to connect it. And then add the I/O marker. And then you can rename the port into something you like. After that, we can view the HDL function. And this is the generated HDL file from the schematic. From here, we can see the RTL schematic. We can also click to view the technology schematic. That means that the primitive gate has been sanitized. In the LUT dialog, you can see the schematic, the equation, the truth table, and the Carnot map. Next, we're gonna using the operator bitwise. operator bitwise is a little different from the primitive gate. If in the primitive gate we're using the schematic input, in operator bitwise we're gonna write the equation first to make circuit. In the new module wizard, select Verilog and then name the module. Then initialization the port, use x1, x2, x3, x4 and f1. x1, x2, x3, x4 as an pin input and f1 as an pin output. And then write an equation on the field. Assign f1 equal x1 and x2 or x3 and x4. And then check the syntax to ensure there's nothing wrong in code. Next, click View RTL Schematic. That means that the primitive gate has been synthesized. And then the rest is pretty much the same as the primitive gate. In this section, we will discuss how to make a combinational circuit with case method. So what is case? The case statement is a decision instruction that chooses one statement for execution. The statement chosen is one with a value that matches that one of the case statement. It works under always block that used to describe events that should happen under certain conditions. Now we'll make mux with for input with case method. Let's see. After we write the code on Verilog, we'll check if the syntax gets some error or not. If there is an error, we can see the RTL schematic. As we can see, the selector goes to pin 0 and pin 2. In RTL schematic, we can also see LUT dialog that contains schematic, equation and truth table from the mux that we have created. Alright guys, I think that's it video for today. Hit thumbs up if you like the video, hit thumbs down if you dislike it. Don't forget to share and subscribe to this channel. And as always, have a nice day.